This video explains the calculation of the development length for 3 and 24 straight top bars in a 600 mm by 350 mm beam, cover 36 mm at the top and 40 mm at the side. Characteristic compressive strength is 25 megapascal. So beam has a 60 mm depth, 350 mm width. It has a top reinforcement 3 and 24 bars. I come back to these figures now, saying that if you have 350 mm depth, we have 3 reinforcement. It each has a 24 diameters, and we have a 40 millimeters side cover. So if I like to calculate the distance from the surface of the reinforcement to the consecutive reinforcement A, we can do the calculation here. 40 plus 24 plus A plus 24 plus A plus 24 plus 40 equal to the length 350. The summation give 152 plus 2A equal to 350. Bring this 350 to 150 across. 350 take away 152 give us 198. 198 divided by 2 give us A equal to 99 millimeters. We will come back to this value really soon. So that value is 99 millimeters. Now the equation to calculate the development length is given on the Australian standard. Now these standards given in AS 3600 2018. In that standards, if you go on page number 182, on page number 182 we have a equation to calculate the development length. These equations that is copied here. Now we can calculate first the factor K1. Now the factor K1 is given on the same page, on page 182. On page number 182 we have a factor K1. This line is written here that I'm not reading it, but the K1 has a two value 1.3 and 1. Now this line, I'll draw the picture here. Now it says that this line, that if the distance from the reinforced surface to the bottom to the underneath, if it is greater than 300, it gives us 1.3, K1 value 1.3. Now in the scenario when it's less than 300, we take K1 equal to 1.0. So if you check the depth of our this is, if you calculate the depth here, which is, let's say 600, take away this 24, take away cover 36, it would be more than 300. In that case we take the K1 value equal to 1.3. Now K2, next factors, we have a K2 here. We're going to find the K2. Again the K2 is given in the standard. If you go back here on page number 182, again in that 182 we have a K2 equations given, that is written here. In these equations, dB stand for the diameter of the reinforcement. This diameter of the reinforcement that is given in the questions 3 and 24. 24 is the diameter and 3 is nothing but is a number of reinforcement, this 3. So we have top 3 reinforcement and this one is diameter. So we substitute 24 here, calculation gives 1.08. Now we need to calculate K3, which is here. K3 we found K1, we found K2. Now we need to find K3. Now K3 has an equations which is written here on the same page 182, and on the close 13.1.2.2 we have this equation. In this one the CD is unknown, but we have known dB and dB. So CD we can get from the figure 13.1.2.2, which is on the page here. On the page here we have various options given here. Now we have a straight bars. In the examples it says that straight top bar. So in that case we are going to use a number, figure number A, straight bars. Now that figure number 8, let me highlight that figure, that for the straight bars mostly we are using that straight bars. So we have 3 distance to recognize. First is the A, that distance from surface to surface of the reinforcement, distance C1 which is the side cover, and C is the distance on the top cover. So if I let's say put the figure here on the side by side, I can see that A distance, which is half A, this is C and this is C1. Now we calculate A equal to, so here CD would be minimum of A by 2, C1 and C. Now minimum A we calculated here in in the last steps we calculate A equal to 99. So I substitute A equal to 99, divide by 2, C1. So please look at here, C1 is the side cover depth. So C1 is here, which is 40. So C1 is 40. C is there is a top cover. So C is a top cover 36. So if I put this one here, which is 36, and that is C, and this is C1, and that is A. So in that case we substitute the value. This 99 divided by 2 give us 49.5, and 40, 36, minimum value is 36. Now K3, we know that this K3 has an equations given in the standard over the page here. K3 has an equation 1 minus 0.15 CD minus dB on dB. So in that case we copy this equation here. 1 minus 0.15 CD, we just calculate 36. dB is the diameter of the reinforcement given here, 3 and 24. 24 is the diameter of the reinforcement. Substitute here, dB is 24. Simplification gives 0.925. Now for K3 we need to check one condition. It should not be greater than 0.7 and not more than 1. Where is written here? That is written here. Here within the limit of 0.7, K3 and 1. What does it mean? So if this calculations comes, let's say 0.6, we need to take 0.7. If these calculations give us 1.1, we need to take 1. So it should be between range of 0.7 and 1, but we have 0.9, so that falls within this range, so that is okay. Now I rewrite this equation here again, that is these equations. In that case we found all the values. 0.5 K1 we found 1.3. If you remember in the previous step, based on the depth from the reinforcement, we found K1 equal to 1.3. K3 we just found here 0.925. Fy is a 500, is a n bars. So if you have a Rio tables, in that n bars we can say that this is 500 megapascals yield strength. Diameter of the reinforcement 24 given in the questions, 24 divided by K2. K2 we found here 1.08. Substitute here, FC value is given, characteristic compressive strength FC is given in the questions 25. Substitute here, that simplification gives 1.336 millimeter. Now there is a one conditions again. Once you calculate this one, we need to check one condition given in the standard here, that once you calculate this one, this answer should be more than this value. Okay, so we just need to find this value. Now this value is 0.058 times Fy 500. K1 we calculated K1 1.3, and dB is the diameter of the reinforcement given in the question, which is 24. That is 904, so 905. So 1136, that is we calculated is greater than 905. So we satisfy that condition from the standard. So now we can just draw it in the format. Development length generally applied when you have beam and column connection that allow to have a transfer of the load from column to beam. So we have a development length from this end of the columns to the beam, which is 113, not should be greater than 113, not less than 1136. So we just rounding up, so take the development length 1350 millimeters. It's for the construction purpose it is very difficult to measure 1336 millimeters, so we can provide the larger, like the rounding number 1350. But for your answers, theoretically if you keep 136 is not wrong, but just for the practical reasons we just take the round number 1350 millimeter. Thank you.